Masters, this is Mrs. Blankwalle trying to finish up section 14.6. So this problem is very similar to problem number 15. It says consider the following reaction, and there it is. Again, I have two initial concentrations. If the third one isn't given, notice I didn't give you CH3OH. We assume it's 0 then. So if it's not given, it's 0. It says at equilibrium, the carbon monoxide is 0.15. What is the value of Kc? Well, let's set up the ICE table. Remember, what does ICE stand for? I stands for initial. So I'm going to plug in the value. Here we go. These are the initials. And what else do we know? They told us that we end up with CO at 0.15. So now it's a matter of, all right, can I figure out, well, what is my C value? So 0.5 minus what is, 0.5 minus what is 1.5. Hopefully you got, this as a value right here. So I'm going to subtract 0.35 and again use your BCA idea where you divide by 1 times 2. Divide by 1 times 1, and those are our values. So now it's just a matter of plugging in some numbers, and here we go. Now we need to solve for Kc. What does this mean? Well, I'm going to use my equilibrium concentrations. So here's my law of mass action. Plugging in some numbers and go ahead and punch it out. And hopefully you got 26. So let's answer this last part. Does it favor the products or reactants? This number is greater than 1. That means the ratio of products over reactants is greater than 1. So if your products over reactants is greater than 1, I have more products than I have reactants, so it's going to favor the products. How else might I figure this out? When I did my Q, well, 0 divided by any number is 0. Isn't it going to go to the right? It has to go to the right because I can't make it go to the left, so I'm going to add more and gain more products this way, and so I know it's going to go to the right and it's going to favor my products. Okay, let's check out the next one, problem number 17. Very similar to number 16. Alright, so I have some methane and I'm going to make some ethine and some hydrogen gas. And so at a really high temperature, I initially have 0.115 methane and I assume 0, 0 of the other two, and at equilibrium, so you got to read the problem. At equilibrium, the acetylene, the ethine, is C2H2 is 0.035, so I do gain some. What is the value of the equilibrium constant? So let's find this out. I got to set up my ICE table. Here it is. I have 0.115 and 0, 0. Now what? The C2H2 gains some, but not a whole lot, does it? Just a little bit. So the question is, 0 plus what is 0.035? Well, here it is. And now what? Take this, divide by 1 times 3. And 0 plus 0.105 is 0.105. So now what? Take this, divide by 1 times 2. So I'm going to subtract 0.070 and I get 0.075. So now I'm ready to do the equilibrium constant. Go for it. Hopefully you found this. Oh, you know what? I didn't write down the law of mass action. Sorry about that. Probably should. And once I plug in those numbers and I chug, I get 0.00827. What kind of number is that? Really small. Okay, this number is less than 1. So if it's products over reactants, that means I have more reactants than products. If you look at these numbers, overall I do. That I make only a little bit of C2H2, and I actually make some more H2 here. But overall, you do favor your reactants, okay, because this number is less than 1. Okay, so that's the end of 14.6. Hope it was good for you.